Okay, so now we will start talking about clustering. We will get into math and we will see some more algorithms like k-means clustering. Then we will see hierarchical clustering algorithms, which is agglomerative and divisive. And then we are end with unsupervised learning. So we are entering the last phases of this course, and I really hope that you enjoyed this course a lot. Okay, as I enjoyed making this course with very curiosity, with very energetic mode. So I think that you're also very energetic till now, and like me. And you may also thinking, hey Ayush, what about the projects? And the projects are in the last section to help you to get feel of everything about machine learning. Means after you learn all of these things, performance matrix, algorithms, now you will be able to build state-of-the-art models. Okay, so I'm very excited to see you all there. And it means in this section, last section, we're building back-to-back project, and the course website is also in the description box below. You can see what problem set is there, and you can download and start working on that problem set. Okay, so I hope that you're watching this video totally worth it. Even I was making video was totally worth it. Okay, so what we are going to start talking about, we are going to start talking about clustering. In our previous section, subsection, we have talked about some of the applications of clustering. We have talked about, let me choose a pen, a good pen. We have talked about applications. We have talked about applications of clustering. We have seen what unsupervised learning is, and we have seen the lot of applications like in biology and business, etc. We have seen the applications of unsupervised learning, and then I've showed you the data. Okay, and then I've given you an overview what we do in clustering. Okay, so let's start with clustering. Okay, so what the clustering is. But don't just bear with me with my handwriting, because I don't know what happened to my pen. It's very working bad, but no worries. Let's start. So here, let's assume that you have this. You have the great. Oops. Why it is not being removed? Let's assume that you have a x and y plane where you have two features. Like this. If I draw a straight line, okay, so here you have this, and let's assume that you have here as a point, here. Okay, you have this as a point, and another point is green ones, which is here. Okay, so no. In unsupervised learning, all data are same. Why I forgot? No worries. I usually forgot everything. Okay, so what you have these features, red features, and you have this here. So what you usually do in case of clustering, you segment your clusters. You segment your data into different clusters. Oh my God, why this not happening? You segment your cluster. So you have this data, so you segment this cluster to be going into this, and the second cluster to be going into this. Okay, so this is your first cluster, this is your second cluster. Okay, so this is your basic thing about clustering that we have talked. Okay, so we'll see some of the terminology in this. So let's draw a very good representation of this diagram. So let me delete all these links and let me choose a black pen. It works best in case of white. Okay, so let me draw a straight line with x plane. Okay, so you have x and y plane, and here you have the data point. Here you have the data point like this, and here you have the data point like this. Okay, so what do? You segment your data points into clusters. You cluster it out. So some of the terminology is you cluster this. Let me draw a good cluster. You cluster this, and then you cluster this. Okay, so let's leave that. I don't want to make it like that. Let's leave that for now. Okay, so you cluster this out, and then what happens? So here is a terminology alert. Means in terminology we have something called as intra-cluster. We have something called as intra-cluster, and inter-cluster. Just listen what I'm saying. Intra-cluster and inter-cluster. So what do I mean with these intra and inter? I mean with this intra and inter is inter-cluster is the distance between the cluster, okay, between the clusters across all the clusters. So inter-cluster is the distance between across the clusters. So here we have one cluster, here we have second cluster. So inter-cluster is the distance between this cluster and this cluster. It's the distance between this cluster and this cluster, so that's why it's known as inter-cluster. Okay, the second type of is intra-cluster, which is the distance between within the cluster, that points within the cluster. So it may be like this. This is called the intra-cluster. This is called the intra-cluster. I hope that you are that it is making sense. You have this x and y plane, and you have this kind of thing, and what we have to do, this is called the intra-cluster, where we have the distance between two clusters, or maybe two or more than clusters across all the clusters, and intra-cluster is the distance between the data points inside that cluster. Okay, great. So we can think something like that is what we want in this case, if we are taking as a terminology that, so we want our intra-cluster to be small, intra-cluster to be small, and inter-cluster to be large. What do I mean with this small and large? I mean with this small and large is you have this intra-cluster. Intra-cluster is the distance between this and this, and the clusters takes whoever is similar, or group is a cluster is just as in it's a grouping of the similar objects that they are similar to one another. So they should be closest. The data point should be closest, and the intra-cluster of these should be closest. Okay, and the intercluster means the dissimilarity between two clusters should be maximum. Okay, so here we have written our optimization objective. We want our intercluster, which I did as in, should be large, and A should be intracluster should be small. Okay, so that's the basic definition of, that's the basic basic terminology that we have seen, and I hope that is making sense. Okay, so we can frame some problem, we can frame something over here. What we can frame is, we can frame an optimization objective, we can frame a evaluation technique, but before that, why do we even need? So let's assume that you have this cluster like this. You have this cluster 1 2 3 4 5 6 7 1 2 3 4 5 6 7. Okay, so here we have this, and who can tell you that these are the perfect clusters? These are the perfect clusters. Either you will tell, hey Ayush, I'm able to see, I can tell that these are the perfect clusters, but assume that we have 3-dimensional, we have 4-dimensional, we have 50-dimensional, we have 80-dimensional, we have 100-dimensional, we have lakh dimensional. So what you will do in that case? So we have evaluation techniques. Okay, we have evaluation technique that will help us to evaluate our clustering or unsupervised learning, or clustering model. Okay, clustering model that will help us ideally to understand, to evaluate how good our clustering is. Okay, so let's see how some of the evaluation techniques. Okay, so the first one we have, which is called done index. Okay, so the first one we have is called DUNN index. So this is a very funny name, but it's a very you can still read about it in Wikipedia page. So it's so let me first write the equation. So D equals, which is the done index, equals to the maximum of I and J, means the maximum distance between I and J divided by, or by, maximum K, maximum distance D dash between K. Okay, so here what I'm telling, here we have this intra cluster, here we have maximum intercluster distance, okay. So ideally it is framing our problem of intra and inter, that our inter should be small and our interas should be large. Okay, so here we are not assuming should be small, we are assuming what is the largest maximum distance. Okay, so if everyone is small, then the largest may be 0.00, like that. Okay, so maybe something like that will be there. So we are just changing this maximum. Okay, we have maximum over here. Just don't be confused, we am telling minimum intra, that just ideally means that you want the distance between intercluster to be small. So that's why you are taking the largest, whoever the have a largest distance. Okay, so that's why so you can evaluate your model. And the denominator simply means that the distance between your intra cluster, okay, the distance between your clusters, the distance between should be ideally large, not too much small. Okay, so that's the and if you sense it's mathematically, you can see that D should be high to be a good cluster. D should be high. Okay, so this is the evaluation technique for clustering your model, and I think that you understood done index. So let's recapitulate what we have seen so far. Is we have, let me remove this, let me remove this. So we have seen that we have some of the terminology. So we have this small x and y plane where we have this 1 2 3 4 5 6 1 2 3 4 5 6, again one more. Okay, so here we have this the distance between the distance between two clusters, the distance between two clusters is called as intra-cluster, means across all the clusters, maybe some cluster will be here, another cluster will be here, it's across all the clusters, this is called the intra-cluster. And the distance between within the cluster, within the data points, is known as the intercluster, and core idea is for any evaluation matrix of your clustering model is your intracluster should be large, and intercluster should be small. Okay, so we have talked about a done index. We have talked about done index. And done index is simply evaluation matrix. So the done index is written as D equals to the max of the distance between I and J, which are two data points, which is obviously intercluster, which is obviously the first numerator is intercluster. Okay, and the denominator is simply the intracluster, where you want the maximum distance between the values. Okay, so this is the basic definition, and you may think, yeah, you have told about intercluster should be small, but we are checking the maximum so that we can evaluate. We are checking what is the maximum in that cluster that has the distance, so we can evaluate. So everyone should minimum, so our D should be high in that case. Okay, so I think that you understood done index also. So let's see one more evaluation technique, which is for clustering, which is just I'm telling you just some constraints to be added. I just have seen the equations. Just some conditions to be added in I and J, where here in I should be greater than or equals to 1, or it should be and it should be smaller than or equals to j, and j should be smaller than or equals to n, and n here is the number of training examples. And for k, constraints of k is your k should be smaller than or equals to should be at least smaller, should be smaller than or equals to n. Okay, so that's the basic definition of that's the basic constraints, but I don't find it's a very kind of thing. But here, just to understand this, the numerator is just a maximum intercluster, and here maximum intracluster. Okay, and the reason why we want to evaluate, so that's why we are taking the maximum. So if it is maximum, then it is bad. Okay, so our D index should be high if you sense it mathematically. Okay, so another evaluation technique that I've seen so far, let me go back actually. Okay, so here I am on my another thing, and let me remove this. Okay, so another technique is here in front of you, which is the Davis-Baldwin index. Davis-Baldwin index. This is also like a Dunn index. What you want, we denote is a dB equals to, we take it as a dB equals to 1 over n, I equals to 1 all the way down to the n, and then you take out the maximum, where j is not equals to I, sigma I plus sigma j divided by the distance between Ci and Cj. Okay, and this is just the clusters. And for more information about what is this, you can refer to a Wikipedia page. Okay, there is a more derivation, etc. has been already done over there. Okay, so that's the Davis-Baldwin index, but most probably the Dunn index used properly in the country, in the whole for evaluation of your model. So let me highlight it, this one. Okay, so we have seen Davis-Baldwin index. Now it's time for learning a little bit more in depth about what the approach means, what actually the definitions of what's the definition of your favorite clustering. Okay, so one line definition I could tell about clustering is, in clustering you have, and it's a grouping. Can I write it? Yeah, it's better to write it. Okay, just bear with me, or you can write with me also. So the clustering is simply grouping of objects, or elements, objects, such that in such a way, I could say in such a way our object in a should be similar to each group where it is in, each group, and differ from another cluster, Okay, so that's the basic definition of clustering, and a very good definition. And in clustering we have two cases, intracluster and intercluster, where we want our intracluster is the measure of distance between just a distance within the cluster, and intercluster is difference between across all the clusters. Okay, so this is the basic definition of a clustering, and I hope that you understood everything. Okay, so now we have seen Dunn index, we have seen clustering. Now it's time for learning about getting into depth of clustering, is about types of clustering, how many types of clustering we get in our life, and then we will just after talking about types of clustering, we will end this subsection, and in the next section we'll be talking about one algorithm, which is k-means, and the next subsection we'll be talking about hierarchical clustering, which is agglomerative and divisive clustering. Okay, so but before that, let's see some of the types of clustering. Okay, so the types of clustering, which includes the types of clustering, let me choose it, the color. So some of the types of clustering are, first one is partitional based clustering. Partitional, I'm just writing in short, partitional partitional based approach or clustering. Okay, so what is partitional based clustering? So assume that you have this that you have this x and y plane, and you have this data point like this, and you have this data point like this. Okay, so what you will do, you will partition it into two clusters and you are done. Okay, so here we have one algorithm which is called k-means algorithm that we'll study in our next subsection, okay, for in a partitional based approach. Then we have hierarchical clustering, hierarchical clustering. Okay, so in these types of hierarchical clustering, we have like a dendrogram. If you have seen a dendrogram, then you know about hierarchical clustering. Just if you know. So let's assume that you have this data point like this. You have this data point. Let me do it here. That you have this here like this. Okay, so you have this 4 points. You have this 4 points, and again you have P1, P2, P3, P4, and if you plot it, the points looks like this. So these two, this P1 and P2 looks close. This P1 and P2, P2 and P3, just assume that this is a P2 and P3. This looks close, so you just cluster it out. Okay, so the P2, so what you do, you just make a dendrogram just like this. That P2 and P3 are now a cluster which is the same, which we can consider P2 union P3. Okay, now these are the two clusters. Now if you see, the closest structure is this P4. So what you will do, you will again make a nested cluster. Now this will look like this, and now what you will do, you will attach P4 over here, P4 as a dendrogram. Okay, and then what you do, then here is this is the P1 is the closest, then you cover it, and then this hole and this hole. Now after that you will be ended up being a dendrogram. You will be able to see a dendrogram which you can see over here. So here after, which is P1 like this. Okay, now you can see, now we cannot we have a large cluster, which we have a large cluster. Now we are done. This is called the traditional dendrogram. You can see on the internet about this. So what we have seen so far, we have agglomerative structure. We are going up, means we are going up like this, means we have this P1, P2, P3, P4. These are own clusters by themselves in first. These are their own clusters. We have 4 clusters over here. We have 4 clusters. Now we cluster this P2 and P3. Then we cluster P3 and P4 because they are close to each other. Then we construct P1 to P4. Okay, so now we got our full dendrogram. Okay, so that's usually agglomerative cluster. We have something called as divisive. We are in divisive, and I'm talking about in hierarchical clustering which is agglomerative and divisive. And divisive, we have given P1, P2, we have something called as P3. Let's assume that we have A, B, C, D. Okay, so A, it's just it will match if I do that, A, B, C, D. Okay, so E, let's assume E also. So you divide this. Okay, so what you do, you simply divise it. Okay, like this. First you divide A and B, A, B as one cluster. Then you divide C, D, E. Then you have C, D, E. Okay, then you divide A and B into different cluster. So you have this whole dendrogram like structure like this. Now you are this is just opposite of agglomerative. We are just here we are making up, here we are making up, here we are making different cluster. Okay, now we divide our C, then we have a D, E. Now we divide our D and E. Now this is our divisive. Okay, so we divide our whole cluster into different groups which are most closest to each other. Okay, we will study in detail about this in our next subsection, where we will talking about hierarchical clustering. Okay, after that we have something known as well separated clusters, where it is well separated clusters. Okay, just I'm writing it's well separated, means you can easily, your model can easily separate, well separated. Then you have the fourth one, which is center based, which is also k-means clustering is this. center based algorithm. Okay, continuity based, we have something called as nearest neighbors, k nearest neighbors. Okay, and then we have density based, which is often known as db scan. Okay, which you will get in problem set to learn about this db scan. Okay, great. So we have seen a lot about clustering, and I hope that you really enjoyed this session, this subsection of clustering. And from the next section we'll be talking about Lowit's algorithm or k-means clustering, but I will definitely try to complete in no time so that you could get a more prone knowledge of clustering and able to make unsupervised learning models. Okay, so let's see just recapitulate what we have seen so far. We have seen what is clustering. Clustering is just a grouping of similar objects in such a way that these objects are similar to each other within the cluster, or our intercluster should be different, should be maximum, and our intracluster should be small. And what is the difference between inter and intra? In inter we have the distance between across all the clusters, and that's why we need a maximum, and we have intra in which our points within the cluster should be minimum. Okay, means more similar, okay, other than the other clusters. Okay, so that's the basic intuition about this and the clustering. Then we have seen how we can evaluate. So I have talked about one evaluation index, which is done index. Okay, and done index, it is used to it is used to evaluate your clustering model. And what it does, it takes out the maximum. What is the maximum in intercluster? What is the maximum to evaluate the performance between 2 points? And it takes out the maximum of the denominator is intracluster, and numerator, the denominator is intracluster, the numerator is intracluster, and the denominator is intercluster. Okay, and then we have something called as Davis bounding block and index. This is just it will take a lot of time to teach this, but it's out of the boundary course, but it's just here. N is the number of clusters where we have a sigma I plus sigma j, and where I is not equal to j, we want the maximum, and then we are taking out the distance between two clusters, and then we are dividing it up. Okay, so that's what the full clustering based models is. Now I hope that you understood about clustering. Now it's time for learning about now it's time to learn about something new, which is in subsection, where we will talk about where we have talked about 5 types of clustering, which is partitional based, hierarchical clustering, and well separated, and center based, and db scan. Okay, so we will talk about partitional, hierarchical, and well separated is also and center based, where your problem set will be on db scan. Okay, so here we are done with this subsection. Now in the next section we'll start talking about k-means. Till then, have a good day.